I'm started, ma'am.
Okay, ma'am. A very good afternoon to one and all. Sorry for the delay. So, due to unavoidable circumstances, we cancelled yesterday's program and will intimate the date and timing of that session by today evening. So, we move on to the third session of this STTP. Start with this program. Learning is a treasure that will follow its owner everywhere. A very warm good afternoon to one and all. It's my great privilege to address you on behalf of the management of Hindustan College of Engineering and Technology and on behalf of Science and Humanities. I extend a warm welcome to all the vibrant participants to this session. I would like to welcome our CEO and Principal, Dr. K. Karunaharan, Deans of the institutions, and our Head of the Department, Dr. K.P. Uma, who gave her full support to arrange this program. My special welcome to Mr. or Joseph Falk to arrange this session. Today, being the third day, I am very happy to welcome the today's resource person, Dr. Or Binoy Balan, Professor and Head, Department of Science and Humanities, Ahalya School of Engineering and Technology, Palakkad. Today, he is going to deliver the topic Usage of Maxima tool in Mathematical Problems. He has more than 15 years of experience. He published more papers in national and international journals. He organized several programs like FDP's workshops. He completed his PhD degree in the year 2017 and his area of interest is topology. Without taking much time, I hand over the session to you, sir. Welcome you once again. The session is yours.
Okay, thank you, Kritika.
Welcome.
Thank you all. First, I take this opportunity to thank the management, then principal, head of the department, to deliver the session in this webinar. So let I continue, start the session now. My session is basically discussing about a software. It's an open source software, that is Maxima. So I will share my screen now to that. My screen is visible now.
Yes, sir. Yes,
Yes.
sir. It's visible.
So our discussion on Maxima tool. So this is before that I will tell about what is computer algebra system. The computer algebra system is a mathematical software. So Maxima is one of the computer algebraic system. So it is a mathematical software which ability to manipulate any mathematical expression in similar way of traditional computation or mathematical calculation for use by mathematician and scientist. Such a system we call it computer algebra system. So our Maxima is one of this computer algebraic system. And in modern computer algebraic system, this graphical representation and numerical calculation is also possible. So let me come through what are the different or some notable computer algebraic system available now. One software it is Form, then Gap, Maxima. Maybe you are familiar with all these things sometime. I'm just give a brief note about all this. What are different computer algebraic systems? So one of the software it is Maxima. So Maple, MathCAD, Mathematica. Mathematica is not an open source. Then Parry /GP, NewPad, Maxima, Reduce, SageMath, Scilab, Symbolic Math, then Toolbox, that is MATLAB. Then SciMP, Wolfram Alpha, Reduce. So these are some notable computer algebra system. So let's see the history of Maxima. This maxima is based on a 1982 version of Maxima, which was developed at MIT with funding from United States Department of Energy and other government agencies. The version of Maxima was maintained by Bill Shelter from 1982 until his death in 2001. And in 1998, Shelter obtained permission from the Department of Energy to release his version under the general public license. And this version now called as Maxima. Now it is maintained by an independent group of users and developers. So that all about the history. Now this Maxima is now it is it's open source. So any programmer or any developers can use and also develop this. The possibility of develop to include the more source codes or packages to incorporate with Maxima. So it is an open source that now before that when we can insert a cell containing input or output. So whatever input cells you have to enter, you can press Control plus 0, some key representation. Then let me come after that discussion on software in detail. I give you the brief idea. Control plus 0 and to get insert the input cell. Otherwise, in cell item, you can see in the toolbar a cell where you can also input the cell value. Output to get also suppose a text you want to insert, that control plus 1. So I'll show now the software of this. This is the window for Maxima. This is window for Maxima. Suppose you want to insert either here now it is you can do the operation like this 2 plus 3, a simple calculation, you get 5. Answer is 5. So this in this window you can see the cell. This is input. This is first input. Then output is now see here. It is output. Okay. So this one is input. This one is output. So in cell you can see you can insert input cell, input text cell like that. So a lot of facilities available. So I'll give the idea like this. So like here file, you can see a file. This file you can open any file you have saved, you can open it, save as in different what do you say, LaTeX format or Word format. Similar way you can save the whatever input you are given here, it shows the output, and this one you can save it as a file. Okay, then edit, view, all this option here available. Now you see the next slide, that is suppose cell containing title, section or subsection. So this one is possible here. You can type in this Maxima, you can type the section like any text you want, that you can do it in this. For example, I press Control 1, Control 1, Control 1, Control. I press Control 1, you get text. You can type the text. For example, I am writing it is document. You can type like this, document. Next, I press Control 2. Under that, you can write document. What the document it is? One, I am taking document. It is mathematics first. Mathematics department. Okay. Next, I am pressing Control+3. You get subsection. students. So whatever files you want to save in next is control 4, you get 1.2. It goes like that, subsections. Okay, so the idea here, uh, not only mathematical calculation, also you can insert text. So that idea I tell about this maxima. Not only this, what you say, uh, mathematical calculation, you can insert some text or paragraph, section, subsection, or like that. So let's see here, when control plus 1, you insert the text. After that, you press control 2, then control 3, control 4 for getting proper subsections. Okay. Then one more thing, after inserting, actually to get to get the output, you have to press Shift Enter. Once again, after
Kindly wait.
is it audible now?
Yes, sir. Audible, audible.
Okay, okay. I'm not seeing anyone.
Yeah, okay.
Okay, okay. So it's clear the idea. Eh? The first idea is you can
Sir,
enter.
slide is not visible.
Slide is not presenting.
Yeah.
Joseph, 1 minute.
Yeah,
My
yeah, sir.
laptop is disconnected. Disconnected.
Yeah, yeah, sure.
Join in. Okay.
Joseph sir, please mute
Yeah.
your audio.
Okay. So network issue actually. Let me come to our discussion once again. So my discussion is on maxima about the software. The software can do mathematical calculation, and also you can type this text document also. Okay, and later you can save all these things in any file format, even latex format also you can save. That is the beautiful thing of this maxima software. Now I think it is audible. Okay. So after that, I discuss one thing to get input after getting output. To get output, what we are doing here, usually you have to press Shift Enter. So always press Shift Enter is difficult. So instead of Shift Enter, to get press only the Enter key is enough. So the idea is you have to take edit to get this option, edit, then configure. Under configure you take worksheet, then you can press here enter evaluate cell. So in my uh, software I put this tick sign. So what happen is, to get output I just press in a keyboard, press only button of what you say enter key. Okay, so that is the idea. Now next is how to install this Maxima. How to install Maxima is, you can take a Maxima 4G. This is Maxima. This is Maxima. If you interest, you please Maxima source. Maxima source 4G 4G.net. This is to download Maxima software. Maxima dot source 4G.net. So you click this, you will get a file for the download option. You can download it. Already Maxima is available for Android version also. For your in your mobile, you can download this Maxima software. Okay. So its file name is, you can see this link, maxima.source for4ge.net. Next is any type of numerical calculation can do in this software Maxima tool. For example, what I suggest here, control, control. I press control 0 to get calculation. 12 divided by 13. 12 divided by 13. Then I press enter. I get only 12 by 13 as a rational form. So to get in decimal format, if I want decimal format, what I have to do is 12.0 divided by 13.0. This will give the fraction value. Okay. So see the difference. If you type 12 divided by 13, you get only its representation, fractional, this rational form, 12 by 30, you will get it. So to get decimal form, what you have to do, you have to take 12.0 divided by 13.0. So here for different division, operation is divide. Okay. And for addition, the operation is plus. For example, if you want 12 minus 13, you will get answer minus 1. If you want power, 12 power is this symbol, power 5. The answer is this. Okay. So these are some operation, some numerical, what you say, some basic calculation of when representing integers, rational numbers. For complex numbers, see how you represent complex number. It is 4 plus. For example, I want to write 4 plus 2i. So it is 2 write star, then this percentage symbol into I. So if you write percentage symbol prefix for this, then you will get representation 4 plus 2i. Okay. These are some example. For factorial also, you will get 10 factorial. Just symbol of this explanatory marks. Okay. Now, for getting mathematical functions, operations, you have to take package FUNCTS functions. So whenever required some operations, we have to upload or we have to take the operation for, in this case, function. See the operation, you have find square root, then I square root, that is for minus case. You are finding square root of minus. So instead here represent I square root, then psi 2 pi by 3, then log 10, then log e. So 1 minute, I will see the operation. The operation we have to take. I request the package function. I'm using the package FUNCTS. This package I request for FUNCTS. Then only I can do the operation of function. Okay. So after this, when I call this function as a package, so which package you want, you just call by using the load as the operation. Okay. So load functions. So I want now square root. I find what is square root of SQRT. Square root of what is operation, square root of the operation, and finding what is square root of 56. What is operation of square root of 56? 2 root 14. Okay. So this is a way we can find the value of square root. See, square root of 5 square plus 2 square. Then sine 2 pi. So very important, this pi I am taking for pi, 2 pi, 2 into pi divided by 3. The value you will get it. Okay. My God. Next operation is, we'll see next operation, this like list. Suppose you want to list this some elements, you want to list it. We can see how we can list the elements like x, then enter. What happened? You see, it lists the element here. You want to list the element x, I call it x ABC, then it lists a comma b comma c. Okay, suppose I want value of what is the element in the second position, value in the second position. So value in the second position is uh, actually value to get value in the second position, value in the second position. Suppose what is value in the second position? I take x of 2 square bracket. So I call this list a comma b comma c by using x. So wherever x I will take, it will take this a b c. Okay, so I take x square bracket 2 means what is the list in this list, which is the second element. So that is the it's give b as the second element. Okay. So the operation of uh, another operation of function. You can take f of x. F of x you can take like this. Instead of equal, you are taking semi this column equal x square minus x plus 1. So that means x square minus x plus 1 now called by f of x. Then if you substitute f of 2, what happened is you will get value when substitute x equal to 2 in that function f of x. If you substitute f of a, what happened is you will get a square minus a plus 1. Okay. So in similar way, if you type u plus v, what happened? In place of x, it substitute u plus v whole square minus u plus v plus 1. So this operation of the function, this f of x, this column equal, you can take. It called now this function x square minus x plus 1. Similarly, you can see norm xy equal square root of x square plus y square. Then now if I'm taking norm of 5 comma 2 means what happened here? It take x value 5 and y value as 2. So in Maxima, you can see the different type of mathematical calculations it can do. And also we see that how a text documents can be typed in this file. So all about you can I will show where all this Maxima tool can be applied. Not only this like this small function, it will extend it to statistics, probability, distributions. Then it may extend it. It can extend it to uh, optimization techniques, Laplace transform, then Fourier transforms, integration, differentiation, calculus. In all calculation, this maxima tool can apply. Graph theory also, graphical representation also possible. Okay, so in this in this session, one and a half hour session, I will just give a brief introduction about all this, how we can use, and also the participants will get an interest on using of Maxima. Remember, Maxima is an open source. In Mathematica, MATLAB, and all, the similar type of calculation can do. So, if you are familiar with this open source, it will benefit it. Okay. Now, another thing is, this is calculation of see one operation. For example, x equal to 9, and I am taking y, that is x plus 3. Now I taking z, this percentage symbol plus 10 means, let's see here, I'll show x equal to 9, then y equal to x plus 3, y equal to, oh sorry, x plus y equal to x plus 2, y x plus 3, y not y. Okay, y is equal to x plus 2. You get y is equal to 11. Now I am taking z, and take operation, this percentage symbol. Sorry, operation is percentage symbol plus 5. So what happened here? You'll get value, the previous value, that is 11. Previous value is 11. That percentage symbol notation for using of previous operation. So from previous operation, the value is 11, then 11 plus 5. Okay. So these are some idea regarding some calculation. Now you can see how the expansion of some basic algebra, like expand, then factorization, then what is numerator, what is denominator, then rational simplification, then full rational simplification. So I'll show one small example. This example I'll show you. A small example. This is I want to remove all the details what I taken first. It remove it now. Okay. Now I'm taking the next operation. So using the symbol kill all. Now I'm taking expression this, uh, expression this. Then I take expand, expansion of this, expansion of this expression. I take the name expression expr. I use the simple name, the simple operation name. It is, oh, 1 minute. Okay, then put enter. So see here, the this x plus 1 whole square, sorry, x plus 1 power minus 2 minus y plus 1 power 3. That is the expansion of this. Okay. When you use this symbol, factorize. So factorize means what happened? Factorization of this symbol. If you simultaneously use operation, then you will understand very easily. So factorization of this symbol, I factorize. Now see, this minus 8y minus 4x plus z square into 2 into 2y plus x. After this, using this uh, operation factor, it factorize it. So some idea about simplification, some basic algebra, expand, factorization, factor. Then if you are using NUM, NUM means what is numerator term in this sin x divided by x plus 1. Denominator, it shows what denominator of sin x divided by x plus 1. Now rational simplification. So simplification can do in more rational form. Full rational simplification means it will again simplify it. So these are some basic some commands to get some operations in basic algebra. Okay. The next is uh, partial fraction. Suppose I will show this example to get a partial fraction. This expression, I type the expression. Next is I take what is partial fraction of this expression. So very interesting. If you are finding any uh, partial fraction of any terms, you will get very simple way this operation. So this one is partial fraction of this expression 1 divided by x cube plus 1. It is the partial fraction form of this expression. So you have to take partial fraction PART FARAC, then bracket expression comma x. So it give the result output the partial fraction form of this expression. Okay. So another trigonometrical simplification. It is another one, trigonometrical simplification. So all the commands, very interesting thing is, whatever commands are using here, it is similar to our calculation, what we are calculating in actual calculation of mathematics. Integrate, differentiate, well, all these cases, its command is similar to that calculation. See, the trigonometric simplification. See, very simple. Trigonometric simplification of tan x, it gives sin x divided by cos x. So all this result now you can see like that. Trigonometric expansion of tan 3x. Trigonometric reduce of 2 cos x square minus 3 sin x square minus 1. Rational simplification. The previous, the symbol, this represent the previous one. Previous operation, what its rational simplification. Okay. Now, similarly, integrate. Suppose you want to integrate x sine nx and taking the value from x value is from 0 to pi. So, integrate operation is this. So, before that, uh, I have to declare one thing here. Uh, because when doing integration, I'm taking sine nx. I'm taking sine nx. So first I see how what is n first. I have to declare what is n. N here it is an integer. I'm taking integer value. So first I declare it. Declare n comma integer. Next I find integration of sine nx. So very interesting all this. you have to integrate. It is possible to integrate definite integral. You can find the integral x sin n x, comma x means it is with respect to x. Next expression for its range 0 to pi. 0 to pi. So output will get what happened. X into sin n x 0 to pi. Actually, you have to get, I think, some x previous expression have some problem. This is okay. Kill all. So it kill all the documents before. Then I see what happened now here. It is integrate sin x sin n x comma x. Some package is missing here. Okay, we'll go to the next calculation. It's very important. Some graphics. How can plot the graph in maxima tool? So one small example. I'll show you a small example here. That is, I'm plotting a sine x. This bracket sign represent the expression of x ranging from minus pi to plus pi. See, figure is coming or not. This figure is up here. Okay, so this is figure. This one is a figure from figure of sine x, and x value is from minus pi to plus pi. Okay, so I hope all of you are following me. The idea of plotting. If you are using plot 2D, not use WX, what happens is it shows displayed in a separate window. Okay, I will show that case also. The graphics will show in a separate window. That is the case. So wherever you want the details to suppose used, you can kill. Kill all means it will not reflect in the coming session. The values what we used in the, see, you get a separate window. If you are simply use what is it, a plot. So see the difference. Using of WX plot 2D, two dimension, or simply plot 2D. So it will give, this will display the separate window for it. Okay. Now another case, you can plot parametric like two functions, that is t minus sine t and 1 minus cos t. That figure also you can plot. But one thing, you have to take parametric here. Parametric comma t minus sine t 1 minus cos t. So you are using a parametric form. So the figure is, will appear now, 1 minute. So this is the figure. WX plot 2D parametric t minus sine t and 1 minus cos t. And the value of t is range from 0 to 4 pi. Okay, so these are some way of getting graphic representation. Another one is, suppose you want to plot a graph for x values are 1, 2, 3, 4, 5, and y values, a table value. Y table value is -1, 2, 0, 3, 4. Let's see how the representation. So only thing is you have to take discrete. You type discrete That is only difference. See, W explore 2D discrete. This is x values 1, 2, 3, 4, 5 are x values. These are y values minus 1, 2, 0, 3, 4 are y values. See, you get a graph for this. X values are plotted here, 1, 2, 3, 4, 5, and this side is minus 1, then 0, then 2, 3, 4 are plotted here. Then this is graph for it. Okay. Now, if you want a style, suppose instead of line, suppose you want the points in like scatter diagram. Suppose you want it is in scatter diagram format. So you can use this style. Style, it is, I take this style here, point. Okay, I use this style is points. See the figure of this case. So this one small scatter diagram of this graph. So very interesting all these things. You can plot a two-dimensional or three-dimensional figures by using Maxima software. Okay. Now another example I'll show, that is three-dimension. Three-dimension case. That is x square minus y square. Joseph, it's audible now. Joseph, Joseph or Kritika, am I audible?
Sir.
Yes or no?
Yes, sir.
Yes, okay. Now see this graphical representation, x square minus y square. X value is from minus 2 to plus 2. Y value is from minus 3 to 3. It is graphical representation. Now suppose you want a grid. You can take a command option like this, grid comma 100 comma 100. And if you want a line with colors, use option here false. False means if you type false means you'll get mesh line colors. Okay, and with symbol dollar sign. And for getting uh, what do you say, instead of plot 2D or plot 3D, you can write draw 2D and draw 3D if you use the package draw. If you use the package draw, then instead of plot, you can use draw 2D or draw 3D. Now, some simplification of solving equations. You can find what are the solution for. Suppose you want to find what is solution of x square minus 1. Solution of x square minus 1. So how you solve? It's very simple. You just take the command solve, then x square minus 1, then x. The solution you get it. That is x equal to minus 1 and x equal to 1. Okay. Now another example. Suppose if you have a system of equation, two equations, x square minus y square equal to a square, then x plus y equal to b. Okay, x plus y equal to b. See what is solution for this, and finding x value and y value. So I use the command like this: x square minus y square equal to a square, then x plus y equal to b, then xy. We'll get solution like this: x equal to b square plus a square by 2b, and y is b square minus a square by 2b. Okay, so these are some major small idea of using of maxima tool in calculation. So in our session, we discuss the case like how maxima tool can apply to type the text content or a section, subsection, all these things we discuss. Then after that we discuss how simplifications, rational simplification, this case like this, some calculation like this, then operation like square root, then how to list the elements, now how to write functions form, then expansion, expand, factor, simplification, rational simplification, full rational simplification, partial fraction form, integrate, then how to use plot the figure 2 dimension and 3 dimension. Okay, then solving of system of equation. So this is another case in numerical method. You usually we use this uh, type of problem, that is how to find the solution of find the root of the equation, algebraic equation or transcendental equation. So I find all roots 3x raised to 5 plus 2x square minus x minus 1. See, you get all values x equal to value. This is one value, another value is this, another value is this, because this is x power 5. So there are 5 solutions exist. So suppose you want all roots of any problem or any transcendental equation. You just use this simple command, all roots, then put in a bracket, take that transcendental equation, then you get the solution, all solution of this. Okay, so it's very helpful in when any staff or faculty handle numerical method problems. Suppose you want to see the solution of some problems, it is very helpful. You want all root means you just type all roots, then bracket that function value. Then system of equation. Suppose you want to solve a system of linear equation. Usually we apply Gauss elimination method. Here it's use this command, linear solve, lin solve. Write all the equation comma, then we need x comma y comma z value. So solution last you get in bracket like this form, x equal to minus 8, y equal to 2, and z equal to 15. Okay, so it is very interesting, all these things. If you are more familiar, if you are work more in this software, then you can see its uh, importance, because this is free software, open source. Now I'll come to optimization. Optimization. So there are two packages. If you are doing a problem of optimization, there are two packages we have to call. One is simplex and other one is cobli. Simplex and cobila. So these are two packages used in optimization techniques. A simplex problem, for example, simplex problem or dual problem, whatever, in LPP problems, we can use package simplex. Cobila is for non-linear programming problem. So that packages can be used for non-linear programming problem. So for this problem, minimize x plus y, subject to the condition 4x plus 2y greater than 3 and x plus 2y less than 2, and this non-restriction, non-negative condition, x greater than or equal to 0 and y greater than or equal to 0. So I use symbol first, kill all. Next I call for the package simplex. Okay, So I am doing here because x values will reflect when I'm taking x in this. So I take kill all. So that gets over. Now I take load. I'm loading the package simplex. I'm loading the package simplex. I hope this will helpful you. This control V. Okay, it is quite simple. What happened? I don't. Okay. Use package load. When I use the package name, this is load simplex. Then this dollar sign if it required. There you go. Sorry. Use dollar sign. Okay. So this package is now used here. Then I just use the command that is minimize LP. Minimize LP. Then first one is x plus y objective condition. Next is in this bracket you write all the constraints value here. Then this one represent the solution x comma y. Here two variable x comma y, two variable. If there are three x comma y comma 3, then end you represent a non-negative LP, that is non-negative linear programming. That case that is equal to true. Then last enter. What happened? It is non-negative. Okay, it's not required this bracket last. Okay, see, it's very simple. The calculation you see here. I use first I load the simplex, then I use the command minimize LP. The problem is minimize. If it is maximize means I use maximize LP. Then this is objective condition. This is our constraints. Then this is our variable. How many variables? Bracket close. Then comma. The last one, the case for our non-negative restriction, non-negative LP is equal to true. Okay, false means non-negative condition not satisfied. That is equal to false. So solution shows 1 by 4. 1 by 4 means that is our objective function minimum value is 1 by 4. Now this 1 by 4 will reach when y is equal to 1 by 4 and x equal to 0. So this is the solution set shows. This first 1 by 4 shows for our solution of objective function. Now this optimum value is reached when y is equal to 1 by 4 and x equal to 0. So this is way of finding the problem like optimization problem or linear programming problem using Maxima software. And also you can solve non-linear programming problem. One thing you call this package Cobila before use that what do you say non-linear programming problem. Next is for maximum also the same. Instead of minimum we use maximize LP. Now let's come to a graph theory session. It is very interesting. In graph theory, we have to before we call the package graph. Okay. Then usage is create underscore graph, write vector list, element of vectors, elements of edge. Then another way is create graph. Take suppose n vectors there, simply write n. Then edge list. Otherwise, you can use the command like this: create graph, vlist, then edge list. If you want directed edges, then write directed. Okay. So what I do now, I take first kill all x or all values, kill all. Now I have used the package. Now is the package graphs. I use the package graphs. I use that package. For example, I'm trying to draw the one graph. I'm taking this G means it is for representing a graph name. That is G I representing G colon create graph of 0, 1, 2, 3. That is vertices. Then edges are 0 to 1, there is an edge, 1 to 2, there is an edge, 0 to 3 is an edge, 1 comma 3. Then close it. Suppose I want directed means comma directed. Okay. So we have graph with the 4 vertices and 4 edges. Now I try to draw the graph of this. So try to draw the graph of this. Graph of G. So it shows when I type print graph, what happen is I'll get the adjacency matrix forms. Okay. Adjacencies of 0, adjacency of 1, adjacency of 2, and adjacency of 3. It gives adjacency details. Next, I see how to draw the graph. How to draw the graph of this. See, this is graph of this G. It is separate window. Here you can copy this graph to your clipboard or save this graph to or print. So many options here. Okay, you can save as a what do you say bitmap or paint. All these things you can do here. Okay, so this is the graph for if you want any edit, you can edit here. There are options for edit. So this is graph with vertices and edges. Okay, now this will give a figure. Suppose you want to adjust the figure color. If you want a line with different color, you can do like this. There is operation here. For example, uh, this last command. Look, last command. That is vertex type is filled square. Then vertex size is 3, and vertex color equal to black. Up what happen is the line will appear in black color. Okay. Now another command I will show, this command, draw graph, show label. So I want the label of the figure, like how many vertices, all the details I want. See, here is it false. 1 minute. Label. Some mistake happened. False. Is it label? No. It's label true only the case. I don't know. It's what happened here. Label with false. Suppose 1 minute. We can use this command. Some problem happened. It appear only true. 1 minute. It's it, this is with the square. Square. Okay. So suppose appear with square label. It is you type vertex type is filled square. Filled square. And vertex size is 3, and vertex color is black. What about next is this is another type 1, that is it is kill all. I have to take kill all first. Some standard figure, you can take some sample standard graphs. The circular graph. Suppose it is a standard, otherwise complete graph. Suppose you want a complete graph. Complete graph with the eight vertices. So this draw is the command. Now use this. Some problem is appeared now. Sorry, I have to use draw. Command is underscore graph. That is the command. Draw underscore graph. Need a dollar sign. Okay. Complete graph. Actually, to appear yesterday, I draw graph. 1 minute. So draw graph, complete graph, kill all. Then I have to take load, because what happened is I'm not using now the package graphs. That again I have to call graphs. Then I have to take draw graph. Now let's see, it will work. Draw graph. Okay. Then complete graph. See what happened. Yes, correct. So this is a complete graph with 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8. So a similar way you can find, you can plot different graphs, some special graphs available. Many graphs available. Standard graph is available. Wheel graph, Peterson graph, Dotka-Hedren graph, cycle graph, a complete bipartite graph. How many vertices you require, you put in a bracket. So this is a way of uh, getting or plotting the graph for the special graph cases. So it's command, look the command, the standard graph available. You just take that name, then underscore graph. Peterson graph, it is a standard one. So Peterson, then hyphen graph. Then put a simple bracket means it is standard one. If you want a wheel graph with 10 vertices, you have to mention 10. If you want it is in 100, you type 100. Okay. So this is the way of seeing all this maxima tool. Now the maxima tool, this is a small idea. I'm giving only a small idea where this maxima tool can apply. In case of simplification in calculus, integration, differentiation, ODE, all this is possible. So this session just brief the maxima can used in wherever possible. Okay, so a small idea on in graph theory we can apply, in optimization technique or we can apply, a linear programming problem we can apply, non-linear programming problem we can apply. In all this area, this software will help you in calculation. Not only calculation purpose, it can, if you want to type any documents in section, subsection, all these things can do by using the command press Control +1. It insert the text. Control +2. It will insert the section. +3, +4 will give the subsections. So I hope this will give a brief idea about maxima tool. So any discussion required, we can clarify the doubts of anything. Organizers.
So thank you, sir.
Okay. So any doubts
Dear
or anything?
participants, if you have any queries, kindly post it in the chat box. So participants are asking you the presentation, sir, the PPT.
Okay. I will share. I will share it.
Okay.
Okay.
Okay, sir.
One more thing, this Maxima
Yes, sir.
you can download in your Android phone also. So in latest or some Android phone, KitKat, all this what you say packages available. That Android phone is suitable for this Maxima tool. So in phone itself, you can see or draw the figure or calculation and all. So that much
Okay.
compatible this Maxima.
So one question from the participant side. Can we use this software for solving optimization problems?
Yeah, optimization problem like linear programming.
So they didn't mention that particularly.
Linear programming problem we can do that we already discussed now. This in our slide, this one
Yes, sir.
optimization. One thing, if you are using optimization linear programming problem, we have to apply load simplex. We have to first load the package simplex. If it is non-linear programming problem, we can use the package cobila. Okay, that is the only thing. So load simplex,
Okay.
then you can apply the command like this, minimize, the problem is minimize. So minimize underscore LP. Then this part, first part is our objective function. Then square bracket. Inside the square bracket, you mention the constraints. Then last one is our variable x comma y. Then close the bracket. Then if non-negative restrictions there, if it is positive, you have to take non-negative hyphen LP equal to true. Then the result will show what is the value of x and what is value of y. So this software, I said no, not only these area, what I explained now in this session, you can apply in statistics, probability distribution. That is, so a command is available to getting probability distribution values and all. Then it can use for Laplace transform, Fourier transforms. In all this, I'm not touched that much into that area. So brief idea only I'm giving here. So that is a possibility is there.
So one more question.
Hmm. Tell me.
Can we do image processing through Maxima tool?
Image processing means, yeah, image processing, I don't know. But fractals can do. Fractals to draw the figures of fractals. Image processing means you are asking improvement of the or images, developing of images. So I don't think we can you can produce the images if you have a function or whatever. You can produce the image. Possibility is there. See, there are packages available. Maybe for image processing, if one person can develop that package, that also can attach with maximum. Okay. So there is possibility is there.
So there are all.
Any other
Okay, sir.
questions?
Yes, sir. They are asking a website for Maxima.
Maxima. This is website. Maxima. My screen is visible now.
Yes, sir. It's
Maxima
visible.
dot source forg dot net. This is the website available. When click this, this is an open source. You can go through here, download, go to download. Now see here all the possibilities here: Windows, Mac, Linux. You can install here. Okay. There are recent recent forms of files available here. So better you press installation of Maxima in Windows. You can see if you click this 5.44, it will download. So this 5.44 is currently using. So when you press here, you will get the file for Maxima file for Windows. Okay. So the details is available. So this is the website for Maxima software. And if you want for Android, that is also you can see for Android. I think in this website itself you will get it. Okay, for Android version, you see it down. This Android version. This is Android. Maxima on Android. So both is available in the same site. Maxima for Android. So this software you can use both interface with both laptop, the desktop, and also with Android. Any other questions?
No, sir, no other questions. Shall we wind up the session, sir?
Okay, thank you very much. So thank you, Joseph.
Okay.
So thank you, Kudika.
Thank you, sir.
Thank you,
Thank
sir.
you. Thank
Thank
you.
you very much, all participants. Thank you.
Thank you, sir.
Sir, it's time to give vote of thanks. Thank you, sir. Thanks so much. It was such a wonderful session, which was so useful to the participants. We learned more new ideas from your presentation regarding Maxima tools for the mathematical problems, sir. Thank you for giving such a wonderful session, sir. Thanks a lot. Next, we thank our HOD ma'am, Dr. KP Uma, for giving us the permission to arrange such a useful session. Thank you, ma'am. We thank all the participants, those who attended the session and made the session great success. Thank you once again. Thank you, sir. Thanks a lot.
Thank you.
Thank you, sir.